Hi, in this video I'll solve a few more equations with using unit circle. Let's look at this one. Sine x equals minus 1 over 2 between minus 180 and 360 degrees. Now, we start solving it similarly. If sine x equals minus 1 over 2, then x is minus 30. Now, we don't even need to draw the circle itself because, it's slightly tricky. So drawing the axis is enough because now I can draw on the axis that minus 30 will be here in a clockwise direction, right? And that value will be minus 1 over 2, right? Now, we know that sine of this angle will also give the same value, minus 1 over 2. So this is also 30 degrees, right? As the interval starts from minus 180, which is all the way around here, right? It starts from here. So I can consider calculating the other x value to be minus 180, right? Plus 30, which is minus 150 degrees. So I'm talking about this angle here. This is minus 150 degrees, which gives me the same value, minus 1 over 2. Now, from minus 180 to 0, I go anticlockwise, and then I make a full round of 360 degrees. This is my interval given here. Now, when I'm doing this, I again revisit these values, right? So when it comes to the angle that the radius does with the positive x-axis, right? It is going to be, I know that this is 30 degrees. It's going to be this time x equals 180 plus 30, which is 210, right? And then I know that there is this 30 degrees here. So the next answer will be this one. So 360 minus 30, which is 330 degrees. So my answers will be minus 150, minus 30, which I get from the calculator, 210, and 330, which I'm going to be listing now. So x is equal to minus 150, minus 30, 210, and 330. As you can see, unit circle wise, it is the same view, right? It is this angle that the calculator gives me, and in reflection to y-axis, it's going to be the same angle here, right? And this is valid from minus 180 to 360. Every single time you make a full round, you have to be writing those answers, adding 360 to your solutions. So it goes minus 150. You add 360 to this, you get 210. Minus 30, you add 360 to this, and you get 330, right? So this is how it works if your interval is not between 0 and 360, but some other number. Another example. Now let's look at this one. Cosine x equals 0.25 minus 2 pi and 0 are my boundaries. So if I go with the unit circle, I don't need to draw the circle. X's are fine. I don't even need to write x and y. It's pretty obvious. Now, cosine x equals 0.25, then x is equal to 1.318 up to 4 significant figures, just to be on the safe side, because generally we have to round the numbers up to 3 significant figures, but I just add one more digit. Now, this angle is here. How do I know that? Because roughly 90-degree angle is 1.6 radians, which is, remember, pi over 2, and this is 3.1, and this is, let's say, 4.7, and this is 6.2, 6.3, whatever you like. But roughly, these are the numbers. You can also, if you're good at this, you can also keep them as pi over 2, 3 pi over 2, and 2 pi. Actually, these are the official ones, but it's best if you know their numeric values to some degree, because then you will be able to figure out that this angle is in the first quadrant, right? And it's the cosine value here, which is 0.25, right? That this angle gives us. Now, the same angle appears to be here, giving the same value, but it's going to be in clockwise direction. So that is going to be, let's say, minus 1.318, right? Now, my interval is from negative 2 pi to 0, right? So basically, negative 2 pi is the full round on clockwise, right, of the radius. So this is negative 2 pi. It starts from here, and it's a full round up to 0. So what I'm trying to say is I have to write this one to calculate this angle here within the interval. So I'm going to get minus 5.145 up to 3 dp, right? And then I have minus 1.318 with 3 dp, let's say. So this angle is already in the given interval. So basically I have two answers. One is this one, the other one is this one. Now, another way of thinking for this answer is that just because it's here, right, and it doesn't fit as a positive value into this, then you just make a full round of this radius and you end up with this value, right? So basically you have 1.318 minus 2 pi if you'd like, reversing these, and you get the same answer. Now I'll solve question 8f on page 127. This is tangent x equals 290, all right? So basically I'm going to go on like x equals, now notice that these are in degrees, so make sure that you change the mode of your calculator to degrees, right? So I'm going to go with tangent inverse of 2.9, which will give me 70.974, let's say 3 decimal places, just to avoid unnecessary errors. Now, let's draw our axis. 70 degrees is here, right? So this is 70.974 degrees, and the tangent values are positive in the first and the third quadrant, and vertically opposite angles are the same, so actually this is also 7.974, right? So within this interval, I cannot accept this as my answer, but I can accept this as my answer, which will be 180 plus 70.974. This will be nothing but 250.974, right? So that's my first answer. A second answer is I'm going to make a full round. Let me show this with black. I'm going to make this full round 360 and then 70.974 more. Let's see what I'm going to get. X equals 360 plus 70.974. This will give me 430.974, right? So this is my second answer. If I write this, finalize this with 3 significant figures, I'm going to go like 251 degrees, and then I'm going to go here like 431 degrees as my final answers. I hope these examples will help you better understand and solve these simple trigonometric equations. You must have a full grasp of this idea, because when you start solving equations like tangent 2x equals 290, or more complex equations where you have to use the trigonometric identities to simplify them first and then solve, right? You will be using this idea as if it's just 4 operations to you, all right? So please make sure that you fully understand this chapter. Thanks for watching.